I am Kalyani Shashikant Soudhary, Faculty of Civil Engineering Department from Vishwabharati Academy's College of Engineering, Ahilyanagar. From today, we will start the online lecture for the subject of Engineering Mechanics. This subject is for first year engineering and the syllabus of this subject is as per SPPU 2024 pattern. Okay, today there is a first unit, that is force system and its resultant. First of all, we will see the introduction of mechanics. In mechanics, we will study the behavior of the body which is in rest condition or in motion after the application of external force. Sir Isaac Newton is widely considered as the father of classical mechanics due to his groundbreaking work in defining the laws of motion and universal gravitation, which laid the foundation for this field of physics. Newton's three laws of motion describes how the object move under the influence of forces. Newton's first law of motion, this is also known as the law of inertia. It states that an object will remain at rest or keep moving in a straight line unless acted upon by an outside force. Newton's second law of motion, this is also known as the law of force. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Newton's third law of motion. This law is also known as the law of action and reaction. It states that for every action, there is equal and opposite reaction. Now, the Newton's law of universal gravitation, which explains the force of attraction between any two objects with mass. This is better understood by this figure, that is, a ball thrown in the air comes back to the surface due to the Earth's gravity. Basically, the object on the Earth is classified into two types. Number one, solid, and number two, fluid. Solid. The objects which has its definite size and shape. In solid, the intermolecular force of attraction between the particles is strong as compared to fluid. Now, the fluid is the object which has the property to flow. Here is the classification of mechanics. Mechanics is broadly classified into three types, that is classical mechanics, quantum mechanics, and relativistic mechanics. Classical mechanics is also known as the Newtonian mechanics. Here we can see the laws of motion which is created by the Newton. In quantum mechanics, we will study that if the distance between the two particles is very small, then the quantum mechanics is used. Relativistic mechanics is used for the study of high speed bodies. Okay. The application of laws of classical mechanics is known as engineering mechanics. Here are some another classifications of mechanics which is required. Okay. Mechanics is classified into two types, that is solid mechanics and fluid mechanics. Solid mechanics again classified into two types, that is rigid body and deformable body. The study of rigid body is in engineering is we will study the study of rigid body in engineering mechanics. Okay. Rigid body is again classified into two types, that is statics and dynamics. And dynamics is also classified into two types, that is kinematics and kinetics. The definition here you can also see the definition of each and every term. And now from here we will also see the each and every term. Okay. Rigid body. It is an imaginary thing. In real life, no body is perfectly rigid. In engineering mechanics, we assume that the body is rigid. That is, number one, the effect of force on the body is neglected. Number two, the distance between two particles remains same after the application of external force. Number three, it does not change its size and shape after the application of external force. Deformable body. The effect of force on the body is considered. The body changes its size and shape after the application of external force. Now, the statics. Study of forces when the body is at rest condition. Dynamics. Study of forces when the body is in motion. Kinematics. Study of forces without considering the cause of motion. That is, the forces are not considered in it. Kinetics. The study of forces with considering the cause of motion, that is, the forces are considered in it. Now, the scalar quantities and vector quantities. Scalar quantities are those which have only magnitude but no direction, and their examples are distance, speed, mass, energy, density, etc. Vector quantities. Vector quantities have magnitude as well as direction. By the figure, you can see the examples of it, that is what is scalar quantity and what is vector quantity. Observe it very carefully. Okay. Now, the tensor quantity. The quantity which has magnitude and multiple directions. The quantities which can be expressed in the form of matrix is also known as the tensor quantity. Its examples are stress, strain, etc. Observe the diagram. There is one magnitude and multiple directions of it. Now, what is magnitude? Magnitude is defined as how much of quantity. Okay. A magnitude is a unit of measurement that is used to specify the size or intensity of an event. Now the direction. Direction is the location of something relative to something else. Direction is the information for the relative position between two objects without the distance information. Observe the diagram. Here you can easily understand what is magnitude and what is direction. Here are some also another figures of it. Observe it very carefully. Now, the force. Force is an external agency which produces or tends to produce, destroys or tends to destroy the motion. Force is a vector quantity and its SI unit is Newton. Here are also some diagram of it. You can easily understand what is push, what is pull, what is gravity force, what is friction force, etc. Now, the definition of 1 Newton force means what is mean by the 1 Newton force? The force required to accelerate a mass of 1 kilogram at a rate of 1 meter per square per second square in the direction of the applied force. Now, the effect of force. Observe the diagrams. You can easily understand the effects of forces. Now, number one, motion. A force can initiate motion in a stationary object or change the motion of a moving object. Stopping motion. A force can stop a moving object or slow it down. Changing direction. A force can cause a moving object to change in its direction. Acceleration or deceleration. A force can cause an object to speed up, that is to accelerate, or slow down, that is to decelerate. Deformation. A force can cause a body to change its shape and size, especially if it is not rigid. Now, the characteristics of force. Number one, magnitude. Number two, direction. Number three, nature or sense. And number four, point of application. Observe the diagram. Already we saw the definition of it. Now observe the diagram very carefully. Read that again. You can easily understand the characteristics of forces. Now the force system. When number of forces simultaneously acting on a body, then the system is formed. That system is known as the force system. Now, the force system, various types of force system and their diagram. In first column, we will see the force system name and its definition. And in second column, we will see its diagram. Number one, coplanar forces. These forces are acting in the same plane. Non-coplanar forces. These forces are not acting in the same plane. Number three, concurrent forces. All the forces are passing through a single point. And non-concurrent forces. All the forces are not passing through a single point. Collinear forces. They are acting along the same straight line. Non-collinear forces, they are not acting along the same straight line. Parallel forces. Parallel forces are those whose line of actions are parallel to each other. The parallel forces are divided into two types, that is like parallel forces and unlike parallel forces. First, we will see the like parallel forces. Like parallel forces are parallel to each other and have same direction. Observe the diagram, okay? And unlike parallel forces are those which are parallel to each other and have different direction. For this also, observe the diagram, okay? Thank you so much.